Hello guys. So in the previous video we saw why co-registration, segmentation and regression are important. That was a theory video. So if in case you have not seen that video and if you don't know why we use co-registration, then you can click on the I button over here to go to that video. So in this video we'll focus on how can we co-register an anatomical image and a functional image and align them together. Okay, that is the task for this video. Okay, previously we have also done realignment. So if I just go to the folder, so this was the subject that we were processing, and we saw that. So initially we just had this task rest dot bold. I mean just a rest NIFTI file. Then we realigned the volume so that we can remove any motion between the volumes. So now we have this realigned and we have the text file over here as well. And this is the mean file, right? So now we'll have to co-register this image, R sub image, with the anatomical image. So over here in the anatomical image, you will have something like this. I mean, it should be a T1 weighted image. The name can be anything, but it should be a T1 weighted image. So let's first go to SPM. Right, so SPM is now open. Right, so before going to co-register, let us first see what is the alignment before co-registration. So I'm choosing the rest image over here and the anatomical image. Okay, so here we have the functional realigned image on the top and the anatomical image below. So actually by just looking at it, we can see that these two images are not aligned, right? But still what we can do is, just to make sure, you can just right click on any of these, go to contour and say all but current. So what this will do is it will give you a contour of this functional image on the anatomical image. If you right click over here on the anatomical image, then the opposite will happen. Then the contour of the anatomical image will be placed on the functional image. Any which way it is okay. Okay, so here you can see that these two are not aligned properly, right? I mean, here also you can see. So these two are not aligned properly. Okay, so thus we have to co-register these two images. Okay, so if you see under co-registration, there are again three options. That is estimate, reslice, estimate, and reslice. Okay, so let us first start with estimate. Okay, so what estimate will do is estimate will actually find out a transformation matrix by which the transformed image, so there will be two images that you want, right? So there is one that is reference. So here I am going to keep the anatomical image as the reference. By reference, what I mean is this will be still, or this other image, or they say the source image. So let me call the functional image a source image for now, and the anatomical image the um, reference image. So what will happen is the source image will be warped or moved according to the uh, reference image. So it'll be moved so that these two are aligned. So where you can see that we want to just move this below. So if this particular image will go down, only then you can align these two, right? So that is the task. Okay, so it turns out that using linear algebra and matrix multiplication, you can actually move this in any direction. So you can move this down, left, right, up, down, and so on. So for that you need that transformation matrix. Okay, so for so this particular co-register estimate will estimate the transformation matrix that is needed to transform this image so that it aligns with this particular image. Okay, so what estimate does is it estimates this particular transformation matrix and then puts it in the NIFTI header of this particular file. It will not change the image or the voxel values, it will just change the NIFTI header. Okay, let me just quickly show you what is the NIFTI header and how you can access it with MATLAB. Let me just go. So this is the functional directory. I'm in the functional directory. What I'll do is, let me just create a temp variable and I'll use NIFTI info. Okay, so NIFTI info is a command in MATLAB that you can use to get the NIFTI file, and you have to give the path. So I'll give the absolute path over here, and then there is R sub. So if you press tab, it will automatically complete the thing. Okay, and then press enter. So here you can see a temp variable is, or temp structure is created. Now these are different things, are the structure or the contents of the NIFTI header. So it has the file name, it has the file modification date, so when was this particular file modified, it has the size and so on. So over here some important things are over here. So image size, what is the NIFTI image size? So it is 64 cross 64 cross 34 cross 152. So there are 64 voxels cross 64 voxels cross 34 voxels and 152 time points. Then there are dimensions. So if you remember, I had told you this is a 3 by 3 by, okay, this 3.0. Okay, so it is 3 cross 3 cross 4. Okay, so in the x direction it is 3 millimeters, in the y direction 3 millimeters, and the z direction it is 4 millimeters. So that is the voxel size, 3 cross 3 cross 4. And the 2 is a TR, or temporal resolution. So after every 2 seconds we have sampled the image. Okay, so that 2 is because over here. Okay, then space units is millimeters. So these 3, 3, 4 are in millimeters, and this 2 is in second. That is what it wants to say. Okay, other important things are over here. So here if you see, there is a transform. So if I just type temp dot transform, you can just place tab, so it'll try to complete, and you can just choose between these. So temp dot transform is again a structure having two elements. So there's t and a dimensionality. So dimensionality means it is a 3D image, and let me just put, okay, so this is the 4 cross 4 transformation matrix that I was talking about. Okay, so just remember, I'll just keep this over here, and we'll see that after doing estimate, these values will change. Only these values will change. The image actually won't, I mean the pixel values won't change, only these values will change. We'll see that. Okay, so first let us start with our co-registration step. Okay, so for now let me do estimate, and we'll see what happens when we do these two. Okay, so when you open the estimate, a batch editor opens over here. Right, so it asks for a reference image. So as I told you, the reference image is our anatomical image. We don't want this image to move. Okay, so here you can also read the summary. So this is the image that is assumed to remain stationary. It is also known as the target or template image. And then there is a source image. So now this source image is going to move. Okay, so here you can either put the mean image as well, or let me just put this one. And then there are other image. Which are the other images that you want to move? So if you see here, there was only one. So you actually have a lot of images, right? You have 152 such images, and there is, so you only want the R sub image, right? So for that you can do this. So now only the R sub images are over here, and you have selected the first one. So let's start with second. Press shift, click these ones, so all of them will be selected. Press done. Okay, so here we have selected the other volumes. The first volume is over here, and then this tells you what objective function. So the registration involves a particular objective function. You can choose other if you want. So for now this is good enough. Then again there's separation. We'll not go into more details in these things. And then there is a smoothing, how much smoothing you want to do. So normally it is also better if you have a smoothing of 5. 7 is also better, but mostly people also prefer 5. So yeah, I mean, this actually depends on your data, depends on how you want to do your code registration. Okay, so here we have done this and just press run, that's all. Okay, so now you can see that there is only one file that has generated. Uh, there is no image file that has been generated, right? I mean, this there are no new NIFTI files that has been generated. So we'll talk about this a little later, but let me just show you how the transformation matrix has changed. So if you just go to NIFTI info and again load this, say let me load it in a new temp so that we can just compare both of them. Okay, and then now uh, so this was the earlier temp and this is the new temp. Okay, so here you can see this was the old matrix and this is the new matrix. You can see now there are some changes over here. These were actually 0, now these also have some values, these have some values and so on. So this is what the estimate actually does. It changes this particular transformation matrix for you. And this transformation matrix will tell SPM that this is how every image should be transformed, and this is the main warping of the image. Okay, hence you can see that there is no new file that is created. Okay, also if you just double click on this mat file that is created by co-registration, and I see it over here. So here also you can see there are different matrices, so different 4x4 matrices. If you see these as well, these actually tell you the transformation for every 152 different volumes. If you see closely, they are actually the same. Let me just do full screen. Yeah, so 2.9867 minus 2.9867. So if you see, all of them are same. So this just tells you the the transformation matrix for each of the 152 different time points that were given to you. Okay, now let us go back to SPM, and these are the normalized mutual information co-registration. That is, this is the cost function that we use, and you can see this was the actual original joint histogram for the people who actually know what is mutual information. And so there is this joint histogram that is actually used, and so the histogram of the T1 weighted image is on the x-axis, and on the y-axis there is the functional image histogram, and you can see how these two things have changed. Okay, and here you can also see the registration output, how good they have been registered over here. So you can again, so let me just again do check reg so that I can also overlap them and show it to you. Again, we'll choose the same images. See, now let me just overlap. Yes, so now you can see how beautifully the functional image is overlapped to the uh, anatomical image. You can see the beauty over here. So this is the main co-registration step, and also you can understand we have just estimated. We did not use realign, or we did not use reslice or estimate and reslice over here. We just used estimated. I'll also show you what happens when you use reslice. So one thing that you can see over here is, so let me also load the anatomical image. So let me go to anat folder and let me have, say, temp1. So let's say temp anat, and I want the anatomical. So this is our T1 weighted. Okay, so we have the temp anat as well. So this is the NIFTI header of the anatomical file over here. Okay, you can see the image size of this file. So this is 176 cross 256 cross 256. You can also see the pixel dimension. They are 1 cross 1 cross 1. So this is a 1 millimeter cross 1 millimeter cross 1 millimeter file. Also you can see that there are only 3 values because this is the anatomical image. This is not the functional 4D image, but rather this is the 3D anatomical image. So here you can see that these dimensions are 176 cross 256 cross 256. However, if you remember uh, this one, so let me use temp 1 now. Yeah, so if you remember over here, this was 64 cross 64 cross 34. So the two dimensions are different. This is having 176 voxels in the x direction, and the functional image has 64 voxels in the x direction, right? So the dimension of both the images are actually different. Okay, so what Reslice will do is, if you click reslice or estimate and reslice over here, what will happen is it will first estimate the transformation matrix and then reslice the image, which will also match the dimensions of the anatomical, the reference image. So in this case the reference image is the anatomical image, so it will also match the dimensions to that. Okay, I have actually done reslice as well to just show you what is the output. So here you can see the output of all the three. So let me just show you estimate and reslice first. So over here, if I go to the func file, and here if I say type, so let me load this only the over here path is different, right? And then let me tell this as estimate and reslice. Okay, so here I have estimate and reslice. Oops, I'm sorry. So what happens with estimate and reslice is you also get one more image file created. So the R sub is the original realigned image. If you choose estimate and reslice, what will happen is you will get one more R over here. So I actually did not put that. Right, over here you can see the image size has changed. So this not only changes the transformation matrix, but this also changes the voxel values or the pixel values in the image. It will make it say of the same size as that of the anatomical image. The size will become, or the source image file will have the size same as that of the anatomical or the reference image size. Okay, so this is the other thing that happens with reslice. Okay, it'll reslice all the images and make them the same as that of the reference image. Okay, so in our case only estimate is required. We don't need to do this because what happens is when you do this, there's super resolution that is taking place. So you are actually increasing the size of the image over here, and for that you actually, there are different interpolation algorithms that are used over here. So because of that it is not recommended at this stage, because anyways at uh, at a later stage we are going to reslice it with the standard dimension. So I'll come back to this in the later video, but remember, for now it is just important for us to just estimate the transformation matrix over here for the co-registration, and it is not important to change the actual image size for now. Okay, we'll do this in a later video. because we don't have to change it to the anatomical image, but we'll have to change it to some standard template which will be useful. Okay, I'll give you more details in that video, so stay tuned. And yeah, so this is what Reslice does. And if you only do Reslice, so then there was only Reslice. So if you do only Reslice, it actually does not estimate anything. So it will just reslice both the anatomical image and the functional image. So let me just show you this. So if I just go for check reg and I go to co-registration only reslice func, let me choose this new file rr sub anat sub. You see, even after co-registration, these two are not yet aligned. Okay, because only reslice will just reslice these images as they were. I mean, it will not estimate any transformation matrix or anything like that. It will see the transformation matrix and just make them of equal size. So now these two are of the same size. Okay, but they are not aligned. Okay, so that is, so you can only use reslice when you know that you have actually estimated the right transformation matrix. For estimate and reslice, it is a good option, but you can only do that when you know that you require both the anatomical image and the functional image of the same size in voxel dimensions as well. Okay, only then this is required. But what we will do is we will only do estimate. Okay, so we have done that in fact. So let's get back to our tube. Right, so we have just done estimate. So that is all for this video. I've shown you how you can estimate the transformation matrix which will be required for co-registration, and that actually completes the co-registration step. In the next step, we will proceed from here and we'll segment the anatomical image into white matter, CSF, and so on, so that we can use them for further processing. Okay, that's all for this video. Thank you so much for watching. Thank you.